All right, the first few problems, let me read the directions here. The first few problems that we're doing, it just says, determine whether the relation represents y as a function of x. And the order that they're saying that in matters. Y as a function of x means x is domain, y is range. If you switch it and say x is a function of y, that would be x is range and y is domain. So just kind of putting that out there. And I didn't rewrite my first few here, but looking at the inputs and outputs, number 12, yes, this is a function. Y is a function of x because every x is mapped to exactly one y. So that's using that's using our definition of a function. For 13, you can see that for several of these values, each x has two y values that it's paired with, so y is not a function of x. The x values 1, 2, and 3 are mapped to two different y values. And then for 19, we're not given same directions for 19 in this section. Excuse me, determine whether the equation represents y as a function of x. We're just not given the graph this time. You're allowed to picture the graph if you'd like. This is the graph of a circle. A circle would fail the vertical line test. We're not allowed to cite the vertical line test for our AP exam though, so I would say y is not a function of x because in our notes we had problems like this. Anytime y is raised to an even power, if you were to try to isolate the y by subtracting x squared to the right side and then taking the square root of both sides, taking the square root of both sides, when you're the one to introduce that in, it generates this plus or minus square root. That means that I can get x values that I plug in and I get plus or minus. So if I plug in 0, for example, for x, I get plus or minus 2 for y. So because each x, not every x is like that, I guess, but because there are x values which have two y values because of the plus or minus y. Not every single x value. If I plug in 2 for x or negative 2 for x, I get plus or minus 0. Well, that's the same thing. That's 0. So that's why I didn't say every x value. Now, piggybacking off of that, number 21, the square root is already in the problem. And that's important because if we were to graph this, we would see something like this. That graph does pass the vertical line test. It has this chunk in the middle where it's undefined. But the square root here is not plus or minus, so that when I do plug in something like 2, I just get the square root of 3. I don't get plus or minus square root of 3. So y is a function of x. The only time you have a plus or minus is if you're the one to introduce, you're square rooting both sides of the equation. That's where the plus or minus comes from. Because this 4 minus x squared, it could, excuse me, when I plug in something in for y and I square it, it could be positive or negative, but I'm squaring it, so it's coming out positive. 23 you should recognize as linear. You can solve it for y if you like to, but y is a function of x. And, did you just write function or not function on your homework? Probably, and that's okay. We'll just say, if we're actually doing this for our AP exam, I'd be surprised if this is a free response question, but I guess write it out. Here's another y squared. We're going to get that plus or minus if we were to solve for y. So y is not a function of x. So in 21, the square root was already there. In 25, I had to be the one to put it in, so I have a plus or minus. 27, these are absolute value bars around 4 minus x. We can think about that graph. We can plug in numbers. Remember, absolute value graphs are like V shapes, right? So, so y is a function of x. if the y is inside, if it's like x equals absolute value y, that's not y as a function of x, because that would be like, if x is 2, y could be plus or minus 2 to make that work. So anyway, and then for the last one, a vertical line is not a function. So y, there's not even a y to speak of. Y is not a function of x. And that's because this single x value, x equals -7, is mapped to an infinite number of y values. I've got the point -7, 0, -7, 1 billion, -7, 10, whatever. So because x has infinite y values matched to it. Okay, so function, not function, we got that down. And then the next section is just evaluating. This is something that you've been doing for years. I just wanted to jog your memory. So g of 2 just means we're plugging 2 in for t. So 4 times 4 minus 3 times 2 plus 5. 16 minus 6 plus 5. 10 plus 5. G of 2 is 15. You do need to show your work for my tests and for the AP test. Just get used to kind of justifying. G of t minus 2, and if something can be simplified, they want you to. That would be 4 times t minus 2, the quantity squared, minus 3 times the quantity t minus 2, plus 5. And again, I imagine we're supposed to go ahead and square this out. So remember, you can't distribute the 4 through first. You're squaring this binomial out first. And then you will distribute the 4 through. I can distribute the -3 through. So 4t squared. Then we're going to have minus 16t minus 3t plus 16 plus 11. So there's g of t minus 2. And then that's different than, try to scooch this over. That's different than g of t minus g of 2. Well, we should get a different answer than g of t minus 2. So this is supposed to show you that, like, hey, you can't like distribute a g through and get the same answer. So that would be equivalent to, here's g of t, 4t squared minus 3t plus 5. We evaluated g of 2 already, so we can save ourselves that work, minus g of 2, which is 15. So this new function is 4t squared minus 3t minus 10. Okay, 34. So v of r equals 4/3 pi times r cubed. By the way, this is the volume of a sphere. Next year in AP Calculus, you'll be using calculus to figure out things involving spheres and whatnot. Spheres and whatnot. For now, we're just evaluating. So v of 3, this is some good fraction work. So let's see, v of 3 is 4, let's make this 4 pi over 3. When you cube 3, or when you raise 3 to the third, you get times 27. Make sure that you're dividing 27 divided by 3. It's like 27 over 1. So that becomes 4 pi times 9. So v of 3 is 36 pi. We would never put that in a decimal form unless instructed to do so, so just leave it 36 pi. Part B is v of 3 over 2. So 4 pi over 3. When we raise 3 over 2 to the third power, we get 3 to the third is 27, 2 to the third is 8. Again, reduce. Do not do 4 times 27 and try to divide it by 24. That's probably going to lead to more mistakes. You're allowed to divide first. 27 divided by 3. So I can divide both of those by 3, make it 9 over 1. 4 and 8 are both divisible by 4. 4 over 8 is 1/2. So what we really have is 9 pi over 2. okay? And then C is V of 2r. So 4 pi over 3. When you raise 2r to the third, you get 8r cubed. 8 does not reduce by 3. So here I would say, what's 8 times 4? That's 32 pi r to the third over 3. All right, for 35, we've got f of y, and for part A, we're finding f of 4. 3 minus square root of 4, that's 3 minus 2, so that's 1. F of 0.25, I would prefer to think of this as 1/4 because there's a square root involved, and I think that it's easier to work with square roots, or it's easier to square root a fraction. Remember, the square root of 1/4, you're allowed to split it up for any fraction. So square root of 1 over the square root of 4. This is now 3 minus 1/2. 6 over 2 minus 1 over 2 is 5 over 2, or 3 minus 1/2 is 2.5. I'm not opposed to mixed numbers, decimals if they're terminating, all of that stuff, but for a lot of our higher level work, it'll be in our benefit to work with improper fractions like this rather than, the only time I really change to mixed numbers is if I'm trying to graph or plot a point. It makes sense to me to switch it to something that's like 2.5. And then part C, 3 minus the square root of 4x squared. Now be careful here, the answer is not 3 minus 2x. It's 3 minus 2 times the absolute value of x. And why is that the case? Or it could be 3 minus absolute value of 2x, however you want to think of that. Why is this the case? Because, think of it this way. Let's go with square root of x squared. If I say plug in 3, square root of 3 squared, square root of 9, that answer is 3. So I put in x and I got x out. So that's fine. But what if I say put in negative 3? Square root of negative 3 squared still becomes square root of 9, still becomes 3, but I put in this x, this negative version, and I got the opposite of that. And so it's not true that the square root of x squared is just equal to x. It doesn't, you're not always allowed, if x is negative, to just cancel the square root and the squared. It's actually equal to the absolute value of that because of order of operations. Order of operations says square the thing first, and then you can square root the positive number, get a positive number out. Okay, 36. Let's see, f of negative 3. So this becomes the square root of negative 3 plus 12 is 9, plus 4. That's 3 plus 4 is 7. Part B for 36 is f of 13. That's the square root of 13 plus 12 is 25, plus 4. 5 plus 4 is 9. Part C, f of x minus 12. Square root of x minus 12 plus 12 is just square root of x plus 4. That's as far as that goes. And, oh, there's no D. What am I doing? Okay, so then 37, q of negative 3. When you plug in negative 3, you get 1 over 9 minus 9. Any non-zero number divided by 0 is undefined. We will get to rational functions later this year, but this would be where we have a vertical asymptote. So can't do that one. That one's not in the domain. Part B, q of 2. And the last one, just to write it down so I don't have to keep scrolling, except I have to keep scrolling, was q of y plus 3. There we go. If we plug in 2, we get 1 over 2 squared is 4 minus 9. So that's fine. We get negative 1/5, 1 over negative 5. And if we plug in y plus 3, we get 1 over let's just go ahead and square it out. Y squared plus 6y plus 9, and then minus 9. So we get 1 over y squared plus 6y. Now I haven't been doing this, but anytime I create new functions like this, I probably should be doing little domain pieces. For this one, x can be anything greater than or equal to 0. For this one, y can't be 0 or negative 6, because that would cause us to divide by 0. I think that's all that applies for now. For 39, I seem to have cut those off, so let's see. 39, f of 9, f of negative 9, f of t. So that was f of 9, f of negative 9, f of t. When I plug in 9, I get positive 9 over 9, which is 1. When I plug in negative 9, I get positive 9 over negative 9, negative 1. When I plug in a different variable, t, I get absolute value of t divided by t, and the only stipulation here is that t can't be 0. Okay, here are some piecewise functions that we're evaluating. So remember, you pick the correct piece based on the domain. So if I want f of negative 2, I need to be on the top piece. This is for x values less than or equal to 0. So square negative 2, you get 4 minus 4, so that's 0. And then for part B, we're doing f of 0. 0 is less than or equal to 0, so again, I'm in the top piece. 0 minus 4 is negative 4. F of 1, 1 is an x value that's greater than 0. So f of 1 gets plugged into the bottom piece only, comes out to negative 1. So you should never be plugging into more than one piece. It's a piecewise function. 45a, f of negative 2. Negative 2 is a value that's less than 0. So f of negative 2 is equal to negative 2 plus 2. That's 0. F of 0 falls into the middle category. The answer is just 4. And f of 2 falls into the last category. 2 squared plus 1 is 5. And for 46, f of negative 4. Negative 4 falls into the first category. Gosh, I just realized these just sort of like take you in order. I will be jumping around if I were to make a worksheet on this. Like, it wouldn't always just be first piece, second piece, third piece. Make sure you're paying attention to what the x value is. I'm not sure why this is like that. I just realized. F of 0 falls into the middle piece. It's 5. And f of 1 falls into the final piece. 4 plus 1 is 5. Okay, that finishes this homework assignment. Please come to office hours if you have questions, or ask at the beginning of class and we can go over anything that we need to.